And that worked. And I don't think I really need to sell you on that's a motivating thing, that students, and especially girls, there have been studies that having real world data is when you're talking about real problems. And so what I want to talk about are 3 examples I've used recently in intro level classes that I think have done a very good things. I want to talk about 3 examples that I've used in sort of increasing levels of complexity. These have all been used in our intro course, which is in Python, and Python has some very nice list processing features that are good for that. But you could use any language for these. You could do it in Java. You could do it in a lot of things. You could even do it in Snap, I think, from things I saw yesterday, if it could handle the data set. But sort of in increasing sizes on things. And the first one is actually a very simple one, but actually it's quite transformative in what you can do. You can find online dictionaries that are massive, and there is one called Enable, or sometimes it's called the Enable Online Scrabble Dictionary, because it's often used with Scrabble. 172,000 words in it. So any possible word anyone could ever come up with is in this dictionary. And it's so much more fun to deal with lists when students can ask questions. You're not saying, here's a list of 20 grades, find me the number of A's in it. You're saying, find me the number of 4-letter words in the English language. Find me how many anagrams there are of a particular word. These are tasks where I sort of introduce the dictionary and I do some boring things with that. And then students come up with questions and say, well, what word length is the most common in English? And in fact, it's very easy to write code. And I threw some code up here. If you're not a Python person, don't worry about this. But this is code. The first one is asking how many 4-letter words there are. You can do that in 1 line in Python using list comprehensions. What is the longest word in English language? These are questions students came up with, and in just class, well, let's find out. Let's write some code. Sometimes I would do it, sometimes they would do it. The little bit more complex one, what's the most common word length? But there in 4 lines of code, we find out that 8-letter words are the most common in the English language. First and last words in the dictionary. Students found that, and there's the great word ziziva. I just love that word. It's so much fun to say. And you all know what a ziziva is? It's a South American weevil. So you'll learn something today. How many anagrams of stale are there? There are 10. That can be done in 1 statement in Python. It might require more in the language of your choice. But the important thing is that in an intro course and very early on, students can ask questions about data and things where they, oh, that's interesting. And they're writing code and they're not just find the average of a list of numbers kind of thing. And it's what makes it interesting is the size. If this is done with 100 words, it's not interesting. When it's 172,000 words, then it becomes interesting to students. The second one, you know who that is? Who is it? Doug McDermott. So National Player of the Year from Creighton. Very exciting for us. This is an exciting basketball year for us, and so to make it relevant, we did some things with basketball statistics and looking at NBA statistics and WNBA as well. You've got to be careful about that. This sports statistics are not for everybody. You need to know your audience and whether that's something that would turn some people off or whatever. But for us, where basketball was very big this year, that was the case. And in fact, the NBA has amazing online resources. And you can do all kinds of data mining and data analysis using their websites. But in fact, it's fairly easy. They don't provide the data files, but you can sort of cut and paste things, filter how you want to. And you can pull out player statistics or team statistics. And I did some exercises in lists where we downloaded these files and played with them. And they wrote code that, for example, you could look up a player, type in a player's name, and it would go through and find it and give you their scoring average for the year. Or that it could find the top players, give me the 5 top scorers in that year, and it would give those to you. And so they could then ask some questions about, well, what is... what are some interesting, if we were looking at assists versus scoring or whatever. And they're fairly basic types of questions, but it was more interesting to them because it was data that they cared about and that they found interesting. And there are a lot of sports ones that are there. But again, you got to be careful about whether or not that's something that appeals. The NBA ones are not, you can't get them in file format, but for example, for a year, if you want player stats, it was about 5 web pages. So I just cut and pasted the stuff, put it into it puts it into I think a tab separated file. And so we ended up, the files that we're dealing with weren't that huge, but the data set that you could pull those files from was quite large. So it goes back, 30 years of statistics you could pull out. I guess I should say one of the things that in the opening one I sort of glossed over. One of the things that I'm looking for in data sets like these is I want minimal overhead for my students. So there are a lot of great websites out there. The Census Bureau has all kinds of stuff. What ends up happening is you really require specialized tools to be able to extract the things you want, or they're in specialized formats and you've got to talk to the students about it. What I want things is that I can get, or I can put very easily in a tab separated file, a comma separated file. So one thing, they can just look at it and see what the data is, although hopefully it's huge enough that they can't really do much with it without programming. But that the access is not an entry barrier for these students, because I'm trying to teach them how to process lists. I'm not trying to teach them how to use a tool for doing data access. Now, the one that I think is the most interesting, and this is where I think I can officially call it big data, is a file I found that has the data of all, which this file is hashtags, smileys, and URLs that appeared in tweets from the beginning of Twitter up until November of 2009. And I don't know why it stops at November, but it does. So there's over 500 million tweets, data from 500 million tweets. And you can get the files sort of organized in different ways, if you want it by month or if you want it by hour. So if you want to look at statistics on when most tweets happen in the day or something like that. But it's a very simple format. So it's basically a certain number of columns where it says this is a hashtag, this is the year and the month it appeared, this is how many times it appeared, and here it is. So in 2009, and what would that be, October, CSTA appeared in one tweet. But this is a massive data set. So it's 1.8 gigabytes, 41 million lines in the file. What I love about this is you can't load this in Word. You can't load this in Excel. And so students who sort of feel like, well, I can just look at anything I want to, even though the format of the file is very simple, it's too big to visualize using the tools that the students know. And so one of the things I start them out with is saying, how do we deal with something this big? And even in a language, it's hard to process something that big. And so the first task that we do is filtering the file. So we want to filter out, we only care about hashtag data. We don't care about URLs and smileys. So let's go through and filter out all the lines that just deal with hashtags. And then to make it easier to analyze, let's filter it out by year. So let's have all the hashtag entries from 2007 in one file, all the hashtag entries from 2008. And what you find then is you get those files down into much more manageable sizes. And I think that's a great lesson for the students right away, is when you're dealing with large sets, is filtering is often a very good first step to do. I'm not going to look at code, but just to sort of show you, I mean, this is the level, that's all the code you need in order to do this kind of filtering in Python, and similar things in whatever other language you're doing for doing things. But what's great about this is that this is this is something they care about, this is something they probably contributed to. And so we can start asking interesting questions, and I pose a few and show examples of code. So let's see the trend in volume for a given year. So what is the increase in the volume of hashtags that appeared? And you can see in 2008 there was a pretty large increase over the course of the year. But I think the one they find the most interesting is going through and finding what's the most frequent tag by month and also by year. And what's really fascinating about this is that it really gets them sort of into a historical state of mind. If you go and look at hashtag trends, you can go back in history and see what people were talking about and what was interesting. So anybody know what 6 words is? Yeah, there was a real thing that went around. There was a big meme that happened actually at the end of 2007, beginning of 2008, where if you could write a poem or summarize your life in 6 words. And it was all over the web, and this was a great kind of Twitter thing because you do it very, very quickly. And so this was a huge thing. And you go back. Just in that year, you could tell that this was a year of the political convention. So the DNC must have happened in August, the RNC, Republican, happened in September. Mumbai in November, there were a series of bombings that happened. And so students, what I would find is we would do this, and then they would actually go and Google and find out what happened in the world during that period. And so it's interesting going through and processing. Again, Python makes this very easy to do with list comprehensions, and amazingly, you can fit a year's worth into a Python list and then just process it. But interesting, when you get into doing it by month, and then, for volume, you can just add up the months. But for the most frequent tag by year, you can't just take the frequent month ones and add it up. It's not the one that appeared the most, and we get into some interesting questions with that. So this has just been a wonderful sort of example where I'm doing the same kind of list processing I did when I made up a list of words. But all of a sudden, it gets students excited about asking questions, and they're using the code to answer the questions that they ask. And I think that's the real big plus of using big data, or big, whatever we want to call it, at the intro level with programming. Now, there are tons more things out there. And so if you're looking for places, and this is all going to go online, so you don't have to type all these if you want to. InfoChimps it's a commercial company, but they have all these free data sets. The one I'm really looking forward to using is 60,000 UFO sightings. So I want to know, what time of day is the best time to go looking for UFOs. That's a great one. A lot of sort of social issues. I'm also a big baseball fan. You can get play-by-play of baseball games. So if you want to find out who is how does somebody hit when the count's 2-1 and there's somebody on base? That information is there, and you can do that kind of sabermetrics on things. Airplane statistics, a lot of these things are public record, and these are things that you can get in a really accessible format, and that's very nice. And then certainly the census has tons of stuff, but their issue is sort of accessing it. It's often sort of a format that's not quite as easy to deal with. Now, one thing I thought about on this, so these slides will go up eventually. I would be really happy if you had great ideas for other data sets. If you sent them to me, I would put them in this slideshow, and then it could be our slideshow and not my slideshow on things. So, of course, I wasn't smart enough to put my web address up there. But Dave-Reed, that's my, Dave Reed, no hyphen, at Creighton.edu. And there's Creighton. Creighton is up there. And I think, we give out emails, don't we, for the conference? I don't know. But Dave Reed at Creighton.edu. If you have a great data set, I'll pass it on and put in here.
Questions? Comments?
Did you say this slideshow is accessible?
Yes,
presentations here will be accessible sometime after the conference.
Yeah, I think we like to say within 30 days we'll have the videos and the slideshows up.
Do you ever just let the students go find the data for themselves?
I have not, but that certainly would be the case. I find these are all examples really from our CS1 course, and I don't find the students that motivated to do that kind of thing there. But certainly at the upper level, we have a capstone class, and students will do that kind of thing. Yeah?
Python makes parsing pretty easy, so maybe this didn't really arise, but how much scaffolding, and just your possible university professor, so maybe it didn't arise, how much scaffolding do you provide to the upfront, parsing and feeding everything into a list, and then making the processing, or?
Well, let me see if I have it here. I'm not sure I do. Virtually none. Because what I'm looking for, and I'm doing that because I'm self-selecting the data sets. So they're all either comma separated or tab separated. And so I give them, in examples that I do, a read data function, which is 6 lines of code that just reads in the entire contents and converts it into a list of lists. And so they're just dealing with a list of lists by the time they get it. But that's code that they could write. I mean, that's something we do in there. But they have that right away. So as long as they could find any file they wanted to that was in one of these formats and be able to work with it. Yeah.
Repeat questions.
Oh, I'm sorry. Did I have to do any scaffolding to make the data accessible to students? And no. Okay. Yeah.
Part comment, part question, but what I have been doing stuff with Java similarly, but as you say, setting up the data ahead of time so that everything's nicely organized, so that, for example, in Java they can just read in, there's 4 fields on every single line, it's all exactly right, so really clean data works really well. And I love the example too because I know a lot of us grew up where, the things that you did where you were finding like greatest common denominator or something like that, a lot of these really geeky math kind of stuff. And I did an interview with Google recently, and one of the interesting things about them was they were saying the fact that, they don't actually, care, none of their computers really need floating point math, because that's passe. It's all about string manipulations and understanding alphabetics and moving things around. And so it's a whole new dimension of stuff that I interest my CS1 and CS2 folks in.
Right, right. Commissioner, yeah.
One of the things you seem very excited about is the idea that they can't process this on their own, independent, without running the program to do it.
Uh-huh.
Do you actually draw that contrast out for them by having them do an example by hand first, and then giving them the big data? Is that valuable to them, or is that?
So is the contrast, I'll summarize and see if I got it right. So the contrast of dealing with the big data and being able, requiring computers to answer questions about data versus toy problems where they can do it on paper. I mean, this obviously isn't the first thing they do with the list. So we're going to start with the list, which is type in 5 things and get the length and get the 4th element and that type of stuff. So obviously we start with toy things because they need to see the really simple, but I want to get to this as quickly as possible because this is where they say, oh, okay, that's why I should know this, or that's why it's interesting to know it.
Put the URL up for the first data set. The word.
Sure. Puzzlers.org is really what you need to remember. Okay.
I'm done.
All right. Thank you.
Thank you.